Good morning, children. Hope you all are good. So in our today's module, we'll be discussing about the law of conservation of momentum from the chapter Force and Laws of Motion. So children, before discussing this topic, first of all, we should know that what exactly do we mean by the term momentum. And I think you have already done that. That what is momentum? So if I'll tell you that momentum is basically the quantity of motion of a moving body measured as a product of its mass and velocity. And we know that momentum is represented by the symbol P, that is equals to mass into velocity. Fine, children? Now we should know that what exactly law of conservation says. And it states, according to this law, the total momentum of a system of objects remains conserved before and after their interaction or collision, but provided that there is no external unbalanced force acting on them, which means that total momentum always remain conserved, that is before and after collision. Fine, children? So now we'll be discussing this with the help of some objects. So we have to consider a system of object of masses MA and MB. So let this object be MA here. This is MA. This MA and MB, let this be MB. Fine. So these are the two objects having mass MA and MB. They are moving with the initial velocities, that is UA and UB. So MA initial velocities UA, and similarly MB initial velocities UB. Fine, children? So both these MA and MB, they are moving with the initial velocities UA and UB respectively, and that is too in the same direction. So what happens? They will collide. Fine, children? After collision, the bodies move with velocities VA and VB respectively. So I'll be making the diagram for the collision also. So you can see here. So they have collided with one another, where Newton's third law of motion takes place, which says that to every action there is an equal and opposite reaction. Fine, children? So this is A and this is B. F AB, and the opposite reaction is F BA. So children, according to Newton's third law of motion, the force AB exerted by ball A on ball B, that is action. So you can see here, this is FAB. So in this situation, what happens? The force AB exerted by ball A, and the force is exerted on which ball? Ball B. So this is action. And the force BA that you can see here, it is a reaction. So in this case, the force BA exerted by ball B, and that is on ball A. So this is reaction. Must be equal and opposite to one another. So can we write this thing as like this? F AB is equals to minus F BA. So I hope this thing is clear to everyone. So now we'll be discussing this, children. See. So we need to consider a system of object of masses MA and MB. They are moving with initial velocities UA and UB. Fine, that you can see here. And after collision, their velocity is basically will change to VA and VB, that is final velocity. And the collision lasts for time t, so we will be writing this as t. Now children, the total initial momentum we should know, and we should also know the total final momentum. Fine, because we need to know the change in momentum. So what is change in momentum? Final momentum minus initial momentum. This is what we should know. And we also know that P is equals to mass into velocity. That is, momentum is equals to mass into velocity. So that you can see here children, initial momentum they are asking. So this is momentum and it is equals to mass into velocity. So mass, you can see MA UA plus MB UB. Fine children. So this is the initial momentum of the system. That is why we are writing here UA and UB. Fine. So this is the initial momentum because we want to know the change in momentum. Now let's just discuss the final momentum, that is the total final momentum. So this will become your MA VA plus MB VB, because V here is the final velocity. Fine children. So we need to prove now that the initial momentum and the final momentum, it remain conserved. Fine children. This is what the statement says, that when two or more bodies interact with one another, so the vector sum of their momentum, it remain conserved or constant. Fine. So this is what we will be discussing now. So children, we need to prove here that MAUA plus MBUB is equals to MAVA plus MBVB. Fine children. And I have already told you this thing, that from Newton's third law of motion, FAB is equals to minus FBA. So we'll be just applying that. So Newton's second law of motion says F is equals to MA. Fine children. So here F is equals to MA. This is M and this is acceleration. What is the formula for acceleration? Final velocity minus initial velocity upon time taken. This is what we have applied here. Fine children. So VB minus UB, because VB is the final velocity and initial velocity is UB for the body having the mass MB and the time t is t. Similarly children, minus FB. So we can take here minus MA. And what about the velocity? Velocity for the body having the mass MA, it becomes, final velocity becomes VA and initial velocity becomes UA, and that is to divided by time. So I hope this thing you have got children. Now see. So now MB, just multiply the MB with VB. So we get MB VB. Then minus, fine, because minus sign is there, bete. So MB UB divided by time. Similarly, multiply with this MA with complete bracket. So that is minus MA VA plus, because minus minus gets plus here. Fine children, MA UA upon T. So this is what we have got here. Fine children. Now if you check it out here, MBVB minus MBUB is equals to minus MAVA plus MAUA, because T get cancelled out with T and we are left with this one. So now the final thing that we have got here is MAVA, because this is minus here, bete. When it will come to this side, it will become plus. So MA sign will be changing. So MAVA plus MBVB is equals to MAUA, and this is minus. So when it will move to this side, right hand side, it will change its sign. It becomes plus. So MAVA plus MBVB is equals to MAUA plus MBUB. We need to take both the velocities together. Fine. So final velocities are together, initial velocities are together. So this is what our final statement is, children. That is ma va plus mb vb is equals to ma ua plus mb ub. So where ma ua plus mb ub, which is this one, children, this is the total momentum of two objects before collision. Remember this thing, before collision. And ma, which means that this one, that maua plus mbub is their total momentum after collision, which remain unchanged or conserved. Fine, children, because I have already shown you the diagram here. So this situation is before collision and this situation is after collision. Fine, that is maua mbub is before collision and mava mbvb is after collision. So this is what they have told us. See now, MAVA plus MBVB. Fine, children. So I hope this concept is clear to each one of you. Fine. There are a lot of applications as well, bete, for this law of conservation of linear momentum. For example, flight of jet planes and rockets can be understood in terms of the law of conservation of momentum. Fine. Okay. Thank you, everyone.